resistance, reactance, and impedance. Okay, we learned about resistance before, right? Resistance, it lowers the current. Okay, it always uses the power. Okay, it lowers the current. So the reactance and impedance almost like resistance. They lowers the current. Okay, when resistance increase, the current decrease. So same as like reactance and impedance. If they increase, yeah, reactance or impedance increase, the current also decrease. Okay, because all of them, these reactance, impedance, resistance, all of them are opposition to current flow. They oppose the current. Understand? They oppose the current. They opposition to current flow. Okay, before that, we need to learn about one very important thing is we must learn back the Phasor diagram. Still remember the Phasor diagram? It's like simple harmonic motion. In semester 1 we learned before that we change the circular motion into simple harmonic motion. Still remember or not? The circular motion is actually a simple harmonic motion. So but this time we have a special name we call Phasor diagram. Okay? So circular motion is like the Phasor diagram. Okay? It's the same thing like before. When this thing, this one is representing the current in the circuit, the AC current. We can say this is the AC current. Okay? So the current is like changing. You know, the AC current in the circuit is always changing magnitude and direction, isn't it? Changing magnitude and direction. So it's like rotating like this. Okay? So the current rotate anti-clockwise. So it has the omega, angular frequency. Okay? So always the direction is anti-clockwise. Don't put clockwise. Always anti-clockwise. Okay? So the current rotate anti-clockwise. So when we translate into the graph, because initially the current is 0. When at x component it is 0. When going up, the current increase, isn't it? And after when the current reaches here, when the current AC reaches, this is all AC. When current reaches here, it is at maximum, I0. Okay? Because this one is actually the y component. The y component of the circular motion, right? Okay? So when it rotates, there, it go back to 0. Okay? And then go down some more. It means go down here. Okay? And then go back to x-axis, means return to here. So this is the time taken to complete one circle is period. Okay? If this graph means it has done 2 revolutions, 2 cycles. So it has 2 periods. Okay? So this graph is a sinusoidal graph, right? So this is the formula, representing the graph. Current is equal to I0. I0 is the peak current. Okay, peak current, maximum current. I0 sine theta or I0 sine omega t. Theta is omega t. Omega is the angular frequency. Omega is the angular frequency. So it is a sine graph. Okay, understand? So it is a sine graph. So this is Phasor diagram. Okay, we will learn more about this Phasor diagram later on. This is important. So okay, now reactance, resistance, reactance, impedance. What are they? So first of all, we have the resistance. Okay, R. Okay, resistance unit is ohm. Okay, and then we also have the capacitor. The capacitor. C is the capacitance. Okay, unit farad. But then we have the Xc. Xc is called the capacitive reactance. Capacitive reactance is just like resistance. Unit also the same, ohm. Okay, ohm. And the formula for Xc is 1 over omega C. Omega is this omega lah. Omega, yeah, is this omega. Yeah, and omega is 2 pi f or 2 pi over period. Period we get from here. Understand? Period we get from here. We can find the omega. Okay, omega. Then substitute omega here. Yeah, omega here. Then we can multiply by the capacitance 1 over omega C. We can calculate the Xc, capacitive reactance, ohm. Yeah, omega is 2 pi f. Xc is equal to 1 over 2 pi fc. And we can see here, Xc is inversely proportional to frequency. Do you see or not? Xc is inversely proportional to frequency. That means if frequency increase, Xc decrease. Okay? But just now the resistance is constant. It does not depend on frequency. Does not depend on frequency. For resistance is always constant. Does not depend on frequency. But for Xc, it inversely proportional to frequency. Later we will learn more about this also, yeah? About Xc with frequency. Then we have the inductance, L. L is called the inductance, yeah? Unit Henry. So remember the self-inductance we learned before? Self-inductance? Yes. It's the same thing. Inductance, inductor is the solenoid. Okay? And we have XL. XL is called the inductive reactance. Inductive reactance. It's the same thing like resistance. Unit ohm. All of them is ohm. Okay? XL is omega L. Yeah? Or 2 pi FL. So for XL, it is XL is proportional to frequency. Just now Xc is inversely proportional to frequency, right? This XL is proportional to frequency. That means if frequency increase, XL increase. Okay? Alright, So, and then sometimes we combine the component. The circuit doesn't just have the one of the component. It has several components put together in series. Yeah, put together in series combination. Sometimes we have RC circuit, we have RL circuit, we have RCL circuit. In that case, they have multiples of resistance and reactance. In that case, if they have multiples, then we call it impedance. Understand? Impedance is like total resistance for the whole circuit. Total resistance. Yeah? Total them is called the impedance. Okay? Unit is ohm. Ohm. All of them are opposition to current flow. They oppose the current. When impedance increase, current decrease. Okay? And you must not confuse between C with Xc. C is capacitance, unit farad. Xc is capacitive reactance. It is ohm. Same to inductance and inductive reactance. Don't confuse between these two. Normally question give you this value, and you need to calculate Xc and XL on your own. This one you need to calculate on your own. Don't assume that C is Xc straight away. They are not the same thing. Sometimes you assume it as the same thing, which is wrong. Okay? Normally question give this C and L, and then you need to calculate yourselves Xc and XL. Okay, so that is about resistance and reactance. Now, okay, so this is one example of the circuit with RCL circuit. It has all three components. You have resistor, you have capacitor, you have inductor, and they connected in series circuit. Okay. So we know that when series circuit, the current is the same for all components, isn't it? Because it only has one circuit. So the same current pass through all three components. Okay? That means the current pass through resistor equal to current in the capacitor equal to current through the inductor, which is the current, the total current. So the current is the same for all components. Okay, this is one very important and basic knowledge. The current is always the same for all components. The current is always the same for all components. Now, so we have the AC source, AC voltage. Okay, AC voltage. So we call it the source voltage. Source voltage. Sometimes you call it source, sometimes you call it supply voltage. Voltage supply. Voltage source. Okay? Then we need to write like this. V bracket source. V bracket source. Okay? And then this one in series. So we have VR, voltage across resistor. We have V across capacitor, VC. We have V across inductor, VL. Okay? How to find the total voltage? How to find the total voltage? Is it, I want to ask you one thing. So we can say a V source is equal to VR plus VC plus VL because it is series. Is this correct? Series what? Series, so we add all voltage together, isn't it? It sounds like incorrect, isn't it? So remember, this is only correct for DC. For DC, for direct current, correct. But for AC, it's wrong. You cannot find the source, the total voltage by adding up all the voltage. This is for AC circuit, it is wrong. It is wrong. Understand? Also, can I say, impedance equal the total resistance? What is the total resistance? Which is the impedance? Can we say that, Z equal to R plus XC plus XL? How do you know? It sounds like wrong, isn't it? So, normally we say it's correct because R plus XC plus XL. So, series, we just add up together, all together we get the impedance, isn't it? Right? But for AC, we cannot do like that. It is wrong. It is wrong. We cannot just add up R plus XC plus XL, we get the impedance. This is wrong. How many times should I emphasize? This is wrong. Okay? Don't just add up all of them, you get the total resistance, total impedance, or get the total voltage. Cannot just add up like that. We need to do things like Phasor diagram. Okay? But very simple. It's just like vector diagram. Okay? Now, okay, put it aside first, yeah? But you remember that. Cannot just add up together to get the total source voltage or add up the resistance to get out the total impedance. Cannot like that. It's only true for DC circuit, but wrong for AC circuit. Okay? For DC, betul. For AC, salah. Understand not? Okay? Alright. Okay, so now you have the peak value and root mean square value because we know that we have peak value, peak current, kan? Also we have the root mean square value, we learned before, right? Now this one is do you see, is it familiar to you? This formula? V equal to IR, that's correct. V equal to IR. This is just V equal to IR, Ohm's law formula. Okay, so the Ohm's law still applies here. Okay, so how to apply Ohm's law? So the V naught source, the peak value means V naught I naught. V naught I naught, V naught I naught, V naught I naught. You see that? Okay, so the peak value, the V naught source equal to, when V naught then I naught also. When V naught then you also use I naught. When root mean square value like V RMS then also use I RMS. Understand? When V naught use I naught. When V RMS use I RMS. Okay? Okay. Good. Okay. So V naught source is the total voltage, right? Yes. Total voltage. So it is responsible for the total impedance. Alright or not? The total impedance. Z is the whole thing, the total load. Yeah? When source total voltage responsible for the total impedance. When voltage across resistor V naught R then equal to I naught resistor only. Okay? When VC XC only. When VL XL only. Okay or not? Yes. Okay? So same thing like that one also. When V source, then I RMS Z. Source means the total voltage means the responsible for the whole impedance. When voltage across resistor, responsible only for the resistor. When voltage across capacitor, responsible for the capacitor only, XC. When voltage across inductor, responsible for inductance, inductive, for XL only. Okay? So, V naught source equal to I naught Z. So, V RMS source equal to I RMS Z. So, V naught C equal to I naught XC. V RMS C equal to I RMS XC. This formula always will be used. Okay? Especially to find the peak current or voltage across each component. Always use this formula. Okay? The XC, XL, you need to the question also asks you to calculate XC, XL. You need to use this formula to calculate. XC equal to 1 omega C or XL equal to omega L. This formula always will be used. And another thing is, if once you find the current, once you got the current is the same for all components. It's the same for the total impedance, it's the same for resistor, also for the capacitor, and also for the inductor. So the current is the same for all components because it is a series circuit. Okay? That's the first part. Okay?